So let's take a few SAQs today. So question number 3. In the last class, we have done 2 questions. Now we'll start with the third one. So find the equation of the cone whose generators pass through the point alpha, beta, gamma and have their direction cosines satisfying the relation AL square plus BM square plus Cn square is equal to 0. This is the question. So first let us write the given point. So the given point is alpha, beta, gamma. And what is the relation given? Relation is AL square plus BM square plus Cn square is equal to 0. Now let the equation of the line through a point alpha, beta, gamma is x minus alpha by L is equal to y minus beta by M is equal to z minus gamma by N. Now the direction cosines. Direction cosines are always denoted by LMN. So how do you find direction cosines? X minus alpha, y minus beta, z minus gamma, respectively. Now since it satisfies, let us take this equation as equation number 1. So since it satisfies equation number 1, so what do we get? In the place of L, we will substitute x minus alpha. In the place of M, we will substitute y minus beta. And in the place of N, we will substitute z minus gamma. So A into x minus alpha whole square plus B into y minus beta whole square plus C into z minus gamma whole square is equal to 0. Therefore, the answer is A into x minus alpha square plus B into y minus beta square plus C into z minus gamma square is equal to 0 is the required cone equation. So let's take the next question. Find the equation of the cone whose vertex is the point 1, 1, 0 and whose guiding curve is y is equal to 0 and x square plus z square is equal to 4. So first it is important to know what do you mean by guiding curve. So guiding curve is also known as directrix, which decides the or which defines the shape of the cone. Which defines the shape of the cone. Okay. So this is about guiding curve. So let's start. What is the given vertex? Given vertex is 1, 1, 0. And what is the guiding curve? Guiding curve is x square plus z square is equal to 4 and y is equal to 0. Now how do you find out equation of line through a given point? We have been using this formula in all the short answer questions. So x minus 1 by L is equal to y minus 1 by M is equal to z minus 0 by N. Now since it cuts the line, y is equal to 0, that is x minus 1 by L is equal to minus 1 by m. Now, because in the guiding curve is y equals to 0, so we are substituting y is equal to 0 here. So if I take y as 0, 0 minus 1 will become minus 1 by m is equal to z by n. Okay, so let's take this as equation number 1, this one, and this is equation number 2. Now if we equate the terms, like if I equate first and second, so I will get x minus 1 by L is equal to minus 1 by m. So if I cross multiply and if I find value of x, so first I take L to the other side, we will get minus L by m, and then I take minus 1 to the other side, we get plus 1. Now the other two terms, if I equate, we get minus 1 by m is equal to z by n. So if I take n to the other side, we get the value for z, that is minus n by m. Now after finding x and z values, let us substitute them. X comma y comma z is equal to, x we got it as 1 minus L by m, y is 0, z is minus m n by m. But we know that x comma y comma z lies on equation number 1. So these values we have to substitute in equation number 1. So 1 minus L by m whole square plus minus n by m whole square is equal to 4. Open the brackets. A minus b whole square. A square plus b square minus 2ab plus n square by m square is equal to 4. Now we substitute LMN values which we got. So L is x minus 1 whole square, m is y minus 1 whole square, minus 2 into L is x minus 1, m is y minus 1, plus n is z square by y minus 1 whole square is equal to 4. That is, from equation number 2, we substituted LMN values. Now we need to take LCM. So y minus 1 whole square plus x minus 1 whole square minus 2 into x minus 1 into y minus 1 plus z square is equal to 4 into y minus 1 whole square. I took the LCM here. Now if we open the brackets, we get y square plus 1 minus 2y plus x square plus 1 minus 2x minus 2 into, now we multiply these two brackets. This into this, this into this, this into this, this into this. So xy minus x minus y plus 1 plus z square is equal to 4 into y square plus 1 minus 2y. Now we simplify it further. So we get x square plus y square plus z square minus 2xy is equal to 4y square plus 4 minus 8y. So we get, now we bring all terms one side. So x square plus y square plus z square minus 2xy minus 4y square minus 4 plus 8y is equal to 0. So if we further solve it, x square, y square minus 4y square is minus 3y square plus z square minus 2xy plus 8y minus 4 is equal to 0. This is the required cone equation. So let's take the next question. Find the enveloping cone of the sphere. A sphere equation is given to us with its vertex at 1, 1, 1. So first let me tell you, what do you mean by enveloping cone? See. Can you see this is a sphere and also this part is a cone? See, this is a cone. And also you can see the base of the cone is a sphere here. Yes, this is a sphere. And this full is a cone from here to here. So an enveloping cone of a sphere is a cone whose vertex lies outside the sphere and the cone's surface is tangent to the sphere at all points along its surface. Okay, so let's begin. So I hope you understand what is the meaning of enveloping cone, right? So
Yes.
now first we will write given equation of a sphere. Given equation of sphere is S is equal to x square plus y square plus z square plus 2x minus 2y is equal to 2. And vertex is given as, usually vertex we take it as alpha, beta, gamma, and that is given as 1, 1, 1. Let's say this is equation number 1. Now what is S1? S1 is we substitute this 1, 1, 1 in the sphere equation. So you get 1 square plus 1 square plus 1 square plus 2 into 1 minus 2 into 1 minus 2. So plus 2 minus 2 cancel. Here 1 plus 1 2 minus 2 cancel. You are left over with 1. So S1 is equal to 1. Now let us write what is the equation of tangent plane. The equation of tangent plane is given as T is equal to alpha x plus beta y plus gamma z plus u into x plus alpha plus v into y plus beta plus w into z plus gamma plus d is equal to 0. So from equation number 1, u is equal to 1, v is equal to minus 1, w is equal to 0 and d is equal to minus 2. So what is the equation of tangent plane? It is given by t. That is, now we substitute the values of u, v, w and d in the tangent plane. So that is 1 into x plus 1 into y plus 1 into z plus 1 into x plus 1 minus 1 into y plus 1 plus 0 into z plus 1 minus 2 is equal to 0. So the tangent plane is x plus y plus z plus x plus 1 minus y minus 1 plus 0 minus 2 is equal to 0. So tangent equation is 2x plus z minus 2 is equal to 0. Now we need to find out equation of enveloping cone. And equation of enveloping cone is given by S into S1 is equal to T square. So x square plus y square plus z square plus 2x minus 2y minus 2 into 1 is equal to 2x plus z minus 2 whole square. So if you further solve it, you will get x square plus y square plus z square plus 2x minus 2y minus 2 is equal to, now we expand a plus b plus c whole square. What is the formula for a plus b plus c whole square? A square plus b square plus c square plus 2ab plus 2bc plus 2ca. So if you bring all terms one side, you will get x square plus y square plus z square plus 2x minus 2y minus 2. Now we bring all right hand side terms to left hand side. So we get minus 4x square minus z square minus 4 minus 4xz plus 4z plus 8x. Now after this we need to simplify further. That is minus 3x square plus y square plus 10x minus 2y minus 6 minus 4xz plus 4z is equal to 0. Always we make sure that x square term should be positive. So we take minus common, we get 3x square minus y square plus 4xz minus 10x plus 2y minus 4z plus 6 is equal to 0. This is the required enveloping cone equation. Now see, this is another question from enveloping cone. So one sphere equation is given to us, one vertex is given to us. So first, let us write equation of sphere. So equation of sphere is S is equal to x square plus y square plus z square minus 2x plus 4z minus 1 is equal to 0. And vertex is 1, 1, 1. Now we will find out S1. S1 is substituting the vertex in the sphere equation. So 1 square plus 1 square plus 1 square minus 2 into 1 plus 4 into 1 minus 1. So that is 1 plus 1 plus 1 minus 2 plus 4 minus 1. Minus 2 minus 1 is minus 3 and plus 3 cancel, that is 4. So we got S1 is equal to 4. Now what is equation of tangent plane? Equation of tangent plane from equation number 1 is tangent is alpha x plus beta y plus gamma z plus u into x plus alpha plus v into y plus beta plus w into z plus gamma plus d is equal to 0. Now let's say this is equation number 1, the sphere equation. Now from equation number 1, if you compare u is equal to minus 1, that is half of coefficient of x is u. V is half of coefficient of y, but there is no y term, so v is 0. W is half of coefficient of z, that is 2. And d is the
How are you meeting?
constant term minus 1. Now we will substitute these u, v, w and d values in tangent equation. So that is 1 into x plus 1 into y plus 1 into z minus 1 into x plus 1 plus 0 plus 2 into z plus 1 minus 1 is equal to 0. So t is x plus y plus z minus x minus 1 plus 2z plus 2 minus 1 is equal to 0. So t is y plus 3z. This is tangent equation. Now how do we find equation of enveloping cone? Enveloping cone is given by s into s1 is equal to t square. So what is s? X square plus y square plus z square minus 2x plus 4z minus 1 into s1 is 4. That is equal to t is y plus 3z whole square. Now let us multiply 4 with the whole bracket. So we get 4x square plus 4y square plus 4z square minus 8x plus 16z minus 4 is equal to, now open the brackets here, a plus b whole square, y square plus 9z square plus 6yz. Now bring all terms one side, so 4x square. Now 4y square minus y square is 3y square. 4z square minus 9z square is minus 5z square. Minus 6yz minus 8x plus 16z minus 4 is equal to 0. This is the final equation for the enveloping cone. Now see, let's take the next question. So find the equation of the cone whose vertex is at the origin and which passes through the curve given by the two equations. So first let me write the given equations. So this is equation number 1 and the second equation is Lx plus my plus nz is equal to p. Let's say this is second equation. Now the second equation I'm dividing both sides by p. So we get Lx plus my plus nz by p is equal to 1. Now substituting second equation in first equation. So what do we get? So ax square plus by square plus cz square is equal to, in the place of 1, I am substituting this now. Let's take this is equation number 2. So in the place of 1, I write Lx plus my plus nz by p whole square. Because this 1 can be written as 1 square, no? This one. From equation number 1, this 1 can be written as 1 square. So we are writing this way. Okay. Now open the brackets. Ax square plus by square plus cz square is equal to Lx plus my plus nz. Like in straight lines, how we do homogenizing? This is the same way. By p square. Now if you cross multiply, you will get p square into ax square plus by square plus cz square is equal to, now open the bracket, apply a plus b plus c whole square formula. So L square x square plus m square y square plus n square z square plus 2 lmxy plus 2 mnyz plus 2 lnxz. Okay, so if I open the brackets, we will get ap square x square plus bp square y square plus cz square. Now I'm taking all the right hand side terms to left hand side. So minus L square x square minus m square y square minus n square z square minus 2 lmxy minus 2 mnyz minus 2 lnxz is equal to 0. So after this, now we are taking x square common. So we get ap square minus L square into x square plus bp square minus m square into y square plus cp square minus n square into z square. Now if I take minus 2 common, we get lmxy plus mnyz plus lnzx is equal to 0. This is the final answer.